We are now exploring item list a little more. We are going to focus on the search method. For the moment, let's not worry too much about the type of the item. Let's pretend that we are storing books, because we want to focus on one aspect of the refactoring rather than look at everything in one fell swoop. So let's assume that we get a string parameter and we want to pick out the element that has an ID that is equal to value. We know that we don't want to use equals to compare the object element that is in this list elements against this value ourselves using the equals method. So we don't want to write element dot equals value, because that is not correct per the equals method of Java. So what we are saying is, okay, let's delegate the responsibility of matching the parameter value against the book's ID on the book itself. Let the book tell me whether this value is matching the ID of the book that I pick out here. So this book here, which I call element, is going to tell me whether its ID is equal to this value. I don't really care how the book does it. So maybe the book will take its ID and then say whether it is equal to this book ID. So this value is passed to the book object's matches method. So I invent a method called matches, put it into the book class, and it will tell me whether this element is equal to its ID. I don't even know that there is something called an ID over here. In the search method, I don't know that there is a ID field. I'm only assuming one thing. The book object will tell me if this matches it. That's it. So that is the intent of this method matches. So now let's make things a little more towards our final goal. So instead of returning a book, we are going to return T. Right? We were saying we are returning book, but we are storing items of type T. So when we search, we get a T back. And let's still assume that we are getting a string parameter. So things have been modified a little more. So public T search, that is the big change here. Instead of book, we have T now. And that is changed here as well. Otherwise, there is not anything really different here. Okay, you can check that. But this parameter is still string. Now, how do we change that parameter to be more general? Instead of string, I would like it to be K. This type of the key that I use to match, that has to be dependent on the element that is being stored. It is going to be dependent on T, the type of element that is stored. So I would like this to be a K. So the generic class item list will have two parameters. One is the type of item to be stored, and the second one is the type of the key used to compare. So let's assume that is K. So there are two parameters now to item list, T and K. So we have one more refinement, T search K value. So the parameter has been changed to K. Now we have a little bit of a problem in the sense, how do we know that matches is a method in type T? We are storing an arbitrary type T, and what is the guarantee that there is a method called matches in that type? How does the compiler know that? How is the compiler to believe that this method will get executed, that there would be a corresponding matches method in whatever type T is? So for this, we invent an interface called Matchable. And it has just one method, matches, and we have a parameter for matches, just like here. Right? Value is going to be K. So this matches method is placed in an interface called Matchable, a generic interface called called Matchable with parameter K. This is not a JDK interface at all. This is a custom interface created especially for the library system, just because of all the difficulties associated with the equals method. So the intent is that any element or any type that needs to be stored in the item list class should be implementing the matchable interface for K. So member implements serializable, and it would implement matchable for string. Book implements serializable and also implements the matchable interface for string. Now let's look at this particular declaration of item list. Public abstract class item list. T extends matchable K, comma K implements serializable. Let's look at the easier parts of this. Public, we made this class abstract because we don't want people to be implementing, or rather instantiating item list. We would like to subclass this as a catalog or member list or something else and instantiate those, because there is no easy way to make this generic class a singleton. That is the reason why we want to make this abstract. And it has to implement serializable. The name of the class is item list, and it has two parameters. One is T, the other one is K. But this looks quite difficult. And what is it supposed to accomplish? Okay, let's take a look. Let's compare it with the previous version of this. We had previously public class item list T comma K. Simply had two types, T and K. You could pass just about any two types for T and K here. They didn't have to be related in any way. For example, T could be book, K could be string. T could be member, K could be integer. T could be transaction, K could be book. There is absolutely no restriction. Okay, so, but you know that this type T and K are related in what way? Well, they are related because we want, I think it is in a previous slide, we want to, that is here, we know that any element that you store here of type T has the matches method. And it should implement the matches method for parameter K. Once again, this type T that is stored in the collection in item list must have the matches method declared because we are writing element.matches and element is of type T. So T should have the matches method and it should accept a parameter of type K. So any object of type T stored here should have the matches method with type K. In other words, any type T stored in this collection should implement the matchable interface with type K. So if T and K are the two parameters, T should be implementing the matchable interface for the parameter passed in the second position. This extends means, T extends matchable means that T is implementing the matchable interface for this parameter, for this type K, where K is the second parameter. And now that is actually taken care of by member and book because they implement the matchable interface for string, and or book implements the matchable interface for string, right? And now we can write catalog extends item list book comma string, because book implements the matchable interface for string. So this is legal. You cannot pass arbitrary parameters. You can't write public class transaction list extends item list with transaction comma string. That will not work because transaction does not implement the matchable interface. So two arbitrary types will not be allowed by Java. You will get a compilation error. And one other thing, you are having catalog extend item list and member list extend item list, and they should be singletons. Now, most of the methods are in the superclass item list, and they have methods that are somewhat more general than things like insert book or insert member, etc. So what is going to happen is, since those methods are missing from catalog and member list, the library class will have compilation errors. So what you want to do is you want to have the methods redeclared in the subclasses with the correct names. Otherwise, you will get compilation errors.